This is Ship It with Justin Garrison and Autumn Nash. If you like this show, you will love the Changelog. It's software news on Mondays, deep technical interviews on Wednesdays, and on Fridays, an awesome talk show for your weekend enjoyment. Find it by searching for the Changelog wherever you get your podcasts. Ship It is brought to you by Fly.io. Launch your app in 5 minutes or less. Learn how at Fly.io.
Hey friends, I'm here with a friend of mine, Dave Rosenthal, CTO at Sentry. So Dave, I've heard you say trace connected before. I know that the next big frontier for Sentry is tracing this metrics platform. But how'd you get there? And what do developers need to know about how you're thinking about this product?
Before I came to Sentry, Sentry was sort of working on a metrics product. We started building that metrics product in a more traditional way, with the metrics just kind of being more like kind of just disconnected. They're just like another source of data. They're another table somewhere. Yeah, you can line them up by time. Sure, you can drill into them a little bit, but really they weren't connected to that trace. And we took a big step back from that after trying it ourselves, after trying it with users, and realizing that there was a whole class of things we wanted to be able to do that you couldn't do with this kind of disconnected metrics. And so, we changed our APIs, we changed our approach, and we're kind of now really on a very clear direction of building a metric system that isn't one of these kind of like legacy disconnected metric systems. It's trace connected so that we can get that kind of rich debugging context when you actually dig into a real problem. And there's trade-offs. It's not quite as easy to just like log random metrics at random times into a system. You have to put the thought when you're building the telemetry into how this metric actually does relate to the structure of the code that's running underneath. But we think it's the right trade-off for users because it's like a little extra time to figure that connection out. But then when you actually go to use the data, the connection's there for you. So small investment, big return. And it's just an example of how we're kind of making decisions internally to set our users up for success with this trace connected idea.
Very cool. It's cool to see how you think about getting to the end result with any of these products you're building. It's so cool to see behind the scenes, the way you think and the way you iterate. Okay, friends, go to Sentry.io. Use our code changelog to get $100 off the team plan. That's basically almost 4 months for free. Sentry.io. Use the code changelog. Don't use anything else. Use our code. It's good for you. Once again, Sentry.io.
Hello and welcome to Ship It, the podcast all about everything after Git Push. I'm your host, Justin Garrison, and with me as always is a very jealous Autumn Nash. How's it going, Autumn?
This is our relationship at this point. Like, you just rub it all in. It's like, look at my 3D printer when you don't have one. Oh, I just went to dinner with Angie Jones, like your hero in life. Like, and not only did I send you a picture, but I ate dinner next to her. Like,
Justin's just walking around like, don't you wish you had all this male privilege? Don't you wish you had my life?
Yo, we talk about that all the time. Like, okay, you have to say this like spicy take because you're like the white guy. You can get away with it.
I drop plenty of spicy takes. I use that privilege, that voice. I will loan it to other people if I can.
He uses it so hard it makes my life.
So actually, it's been really interesting for me because, like, I got decently successful in tech before I transitioned, and then I transitioned, and so I've been able to see in real time people, like, literally respected me less.
What?
But I remember how I used to be treated, so I will walk up to people and I will go, treat me like you did in 2021.
Oh my God, we're best friends forever. Like, I love you so much.
With us on the show today is Hazel Weakly. Hazel, thank you so much for joining us.
That was the best introduction for Hazel ever. Okay. Wait, but not only, wait. It's an audio podcast, so y'all can't see, but Hazel's dressed to the nines. Like she just won like best Ship It dressed ever. Like,
We now have a competition for
I know.
dressing up for the Ship It podcast, an audio podcast.
Mhm.
This is great. But you said it's I mean, we're recording this on November 1st. It's just after Halloween, which all of us tend to get dressed up a little bit. I got dressed up. Autumn, you had a costume too. I forget.
I went as a skeleton to San Francisco, and San Francisco Halloween is just wow. It is wow. I was not prepared.
But also, like, November 1 is just an off by one of Halloween. So the show for Halloween is fine.
I go straight from Halloween to Christmas. So then, like, I Halloween for a little bit, like, later, and then, like, I just go straight into Christmas. I pretend like Thanksgiving doesn't happen and it's just a free day off.
It's a free 2 days for us in these states, right? So enjoy it.
That's how we know you have a good employer that gives you 2 days.
That's true. I guess it's not free 2 days everywhere.
Again, your damn privilege, Justin. The other week he was like, I didn't have any meetings today. I was like, we're just rubbing things in now? Like, look at my 3D printer that didn't get lost in the mail in the background.
I was going to talk a little bit about going to All Things Open, which was fantastic. Autumn, you just went to GitHub Universe. But I feel like, I mean, those are, by the time this comes out, those are like a month behind us. So we should probably just.
But y'all, like, GitHub Universe was the detail, like hackable badges, like every detail was on point. Also, the Dungeons and Dragons, like, deployed for Kubernetes, like the top 10 OSWAS was amazing. I have never saw something that was actually so informative, but nerdy funny and so many jokes. And you almost forgot that they were telling you a list of, like, security things because it was so good. It was like a nerd, like, religious experience. And it was amazing. Also, I met the coolest people. I gave a talk to. That was okay because, you know, peopling and being in front of people.
My talk got rejected because I'm not cool enough. And so I cannot even begin.
You are so cool enough.
We're going to be best friends. But I cannot even begin to tell you how much FOMO I had over GitHub Universe. I didn't expect to have this much FOMO over it.
I think it's because it couldn't handle all of us in the same room. Like, can you imagine if we were together for GitHub Universe? Oh my God. It would have been like a neon explosion of we have to make this happen. So you're submitting a talk for Scale so we can all go together, right?
I am not committing to anything on camera or recording.
We're recording, so no.
We almost got her. Just submit the exact same talk from GitHub Universe to Scale. Boom. Copy paste.
What I will say is, allegedly, I am planning
Allegedly.
to submit a CFP for Scale and SRECon. And if anybody wants me to be hilarious on camera in front of people, they should definitely ask me to submit a CFP because that raises my probability of remembering from 5% to more than that.
Us, Hazel, we want you to be hilarious. You have to tell us about you, Hazel, for all the people that don't know you, even though I feel like everybody knows you, and if they don't, it's kind of lame, but, like, tell us about you.
So it's really interesting. Well, especially the everybody knows me thing. That is the weirdest true but not true thing I've had, because I feel like a lot of cool people know me somehow, and then a whole bunch of other people know me, and then nobody else actually knows me. Like, I'm not even a micro celebrity. I'm not even like a niche micro celebrity. I'm like that one weird kid in the corner that people talk to because they're like entertaining, and they get invited to some of the parties. And like in 2 years, they'll be a micro celebrity. But I'm like in the weird twilight zone right now. But in terms of like what I do and about me, and etc., I do infrastructure things, computer stuff. I break things. But a lot of the most interesting things I think about are community building, figuring out how to build sustainable structures for people and generate ways to give them psychological safety and ways to help them with their innovation, and figure out how to take the concept of wholeness and self-actualization and community actualization and kind of blend all of that into one happy pile so that everything works well. And what I mean by that is, I used to think that you had to compromise between doing the capitalism and having an effective, like, healthy, happy team. Like, it was a choose 2 out of 3. that I found out that actually it's not a choose 2 out of 3. You can actually choose 4 out of 3. You can get even more by leaning into that humanity, the vulnerability, the empathy, the wholeness. And so that's what I do.
Okay, friends, I'm here with a new friend of ours over at Timescale, Avthar. So Avthar, help me understand, what exactly is Timescale?
So Timescale is a Postgres company. We build tools in the cloud and in the open source ecosystem that allow developers to do more with Postgres. So using it for things like time series analytics, and more recently, AI applications like RAG and search and agents.
Okay, if our listeners were trying to get started with Postgres, Timescale, AI application development, what would you tell them? What's a good roadmap?
If you're a developer out there, you're either getting tasked with building an AI application, or you're interested and you're seeing all the innovation going on in the space and want to get involved yourself. And the good news is that any developer today can become an AI engineer using tools that they already know and love. And so the work that we've been doing at Timescale with the PG AI project is allowing developers to build AI applications with the tools and with the database that they already know, and that being Postgres. What this means is that you can actually level up your career, you can build new interesting projects, you can add more skills without learning a whole new set of technologies. And the best part is it's all open source. Both PG AI and PG Vector Scale are open source. You can go and spin it up on your local machine via Docker, follow one of the tutorials on the Timescale blog, build these cutting edge applications like RAG and such without having to learn 10 different new technologies, and just using Postgres and the SQL query language that you'll probably already know and are familiar with. So yeah, that's it. Get started today. It's the PG AI project, and just go to any of the Timescale GitHub repos, either the PG AI one or the PG Vector Scale one, and follow one of the tutorials to get started with becoming an AI engineer just using Postgres.
Okay, just use Postgres, and just use Postgres to get started with AI development, build RAG, search, AI agents, and it's all open source. Go to timescale.com/AI, play with PGAI, play with PG Vector Scale, all locally on your desktop. It's open source. Once again, timescale.com/AI.
You've kind of already been on the show, on Ship It at least, because on last week's episode, last week's or 2 weeks ago, we were talking to Preston about Hachyderm. You were brought up repeatedly as someone that was helping do the migration and run the infrastructure and set that up in a way that was safe and sustainable for a community run project, where it's like we actually have on call for this infrastructure that we're running that builds out a bigger community. So it's like a sub community enabling a much larger community. So I feel like what we've already talked about you on the show has been exactly what you just laid out of something that you've been doing.
It was like Hazel part 1, and this is part 2 with you actually on it. That's how much we talked about you.
And this part 2, Hazel, you nerd snipe me like bad on LinkedIn with one of your posts talking about abstractions. And that was immediately where I was just like, I want to come talk about this some more. So on today, one of the things I really wanted to focus on was started as a LinkedIn post, but then became a blog post. We'll link it in the show notes, where you talk about home-baked abstractions and store-bought implementations, which I think is just a fascinating way of thinking about platform engineering and infrastructure in general. Can you talk about that a bit more?
Yeah, absolutely. So I actually ended up nerd sniping myself on this, which is how essentially all of my blog posts get written. I either get really mad and I yell at the internet, but politely, or I nerd snipe myself and end up writing about it.
That's what blogs are for.
Yeah, right. I know I have ADHD. You couldn't tell. But it's, so the home-based abstraction store-bought implementations, that started from looking on LinkedIn, and John Cutler actually had a post on LinkedIn that was talking about abstractions, and Charity Majors was talking about it as well. And there's this concept of what's a good abstraction, what's kind of not a good abstraction, how do you think about this? Because one of the easiest things to do in engineering is not necessarily even build the wrong thing, but build a thing that doesn't really work in terms of integrating with other stuff and integrating with the future. And that's one of the things that we take for granted with the physical world. The amount of constraints that you have in the physical world because of the laws of physics are enormously useful. Like if you want to allow people access into a building, there's only a couple general concepts. The building needs to not have a wall somewhere. And you can like mess with it a little bit, but you can't invent a teleportation device. And you can't do some weird sort of like inverted trapdoor or like you have so many constraints that allows you to build these deeply reusable abstractions to the point that you can go into a hardware store and buy screws and they work with a screwdriver. You don't need, a custom screwdriver. You don't need these things. And part of that is, the thousands of years of evolution of putting things together, but also the constraints are really interesting. When you remove those constraints and you have the digital world, you enter something really fascinating, which is, to me, one of my favorite topics. And that is, what is it and what does it look like for human thought itself to be the tool that we build on top of and that we treat as a tangible thing? That we treat as, what are we building our towers of abstraction of? It's thought, it's patterns, it's understanding, collective knowledge, institutional knowledge of our society. How do we get better at that? Because right now we can handle like maybe 2.5 layers, maybe on a good day of abstraction, and then we rewrite it in 2 years. That's not sustainable. And it's also not effective.
Now, I don't know if I 100% agree with that, only because we've been migrating platforms for pretty much as long as I've been in technology. Like every couple of years, it feels like there's a new understanding of how things work. And then we just say like, oh, actually, this is the new best practice, or this is the new common way that people think about this stuff. So we're just going to rebuild everything on this new common thinking, right? Because even like 8 years ago, it wasn't containers for most people. And now we're kind of like, oh, this containers thing is pretty solid. We're just going to keep moving that. So VMs before that, it was physical servers before that. Whether those things are similar or not over time, and you're just like, oh, it's just a smaller computer, right? It's like, kinda, but not really. But there has to be this like collective intuition about how the systems work, and we all kind of have to move. We have to move a little bit together to make sure that everyone is on the same page of like, oh, if you're going company to company or environment to environment, like you still can operate the system and understand some of those abstractions just because of a collective knowledge of what technology has available, what computers can do, and those sorts of things, right?
Yeah, but I think there's two different contrasts to that. Look at some of the companies that are still on Cobalt. You know what I mean? Like a lot of government-run technology is so old. Like the way that like just the new codes are and everything is so old. So some parts are moving.
I mean, legacy runs the world for sure. Like legacy is where all the money's at, but also.
So it just seems like there are some things that withstand the test of time, and you can very much so get stuck in that realm of what was built, And just like we were talking to when we did like the space episode, like if you put something out in space, you're not going to be upgrading it all the time. So I think that's like a trade-off. Some things you're going into it and you are not going to be switching things out every couple of years, and it has to be good the first shot or the first couple of shots.
I mean, there's a difference between good enough and upgrade, right? Because it's like, oh, those Cobalt systems, guess what? They just still make money and it's fine. We don't need to modernize it, right? Like there's plenty of mainframes out there. There's all that stuff still exists. We don't need to add a new abstraction to that. But for taking things forward and to trying new things, I feel like every few years we kind of reinvent some abstraction.
So that is something I was hoping we would get to, because you fell right into my trap. But so there's two parallel concepts here that I think, or two slightly different ones. One is this notion that I think that Justin's getting a bit more to, of abstraction being how we approach a problem, how we understand it, how we think about it. For example, we had computers, and then we had VMs, which are, portable computers, and then we have containers, and then we have, functions and WASM, and we have servlet, we have different types of runtimes, and what we think of as a program changes all the time. And we have the other side of things with, do we need to rebuild our infrastructure? Do we need to churn things? Do we need to sort of rip things out almost for the sake of ripping out? Is that progress? And I think you can actually reconcile those two viewpoints by considering actually the geological process of compactification. So with compactification, you have dirt and it's loose. You can move it, you can play with it, it's there. And then over time, the dirt actually gets sunken into the ground and becomes more compact, becomes tighter, becomes more ossified, and eventually it will actually become stone. And so one of the biggest things that I've noticed in the tech industry in the last particularly 5 to 10 years, but even in the last 15 years, is it feels like as an industry, we have stopped doing this process of compactification. So, like, imagine, for example, it's 2002, and threading isn't even a thing in the Linux kernel. But now we have threading, we have multiprocess, we have containers, C groups version 2. We have essentially, you have this pattern for most of computing where you would build kind of an abstraction and the other layers didn't go away, but you compacted what you needed to consider as a programmer when building things. So like before, TCP and UDP and all these other, someone had to invent those. You just used to send packets over an interface. And that was what you did. You just made up your own protocol on the fly. And eventually we came up with TCP, we came up with UDP, and now we have HTTPS and all these things, and just don't think about it anymore. And then you can patch that and keep going. And we have WireGuard, which is one of my favorite examples of this type of process. Like, 10, 20 years ago, a VPN was a big deal. It was complex. It was annoying. Encryption was a big deal. Encrypting network was complicated. And now you have that literally built into the operating system to the point where it's ergonomic and everything can build on top of it. And now you're seeing all these really, really cool things coming out, and eBPF is the same way. But we don't, in the more user-facing side of things, have that process of compactification that I notice. And that makes building what I consider real abstractions really, really difficult, if not nearly impossible.
Go into that a little more about what you mean by a real abstraction.
So I talk about this in the blog post, but what I think about with the real abstraction is we don't really have a good name for it in the language, but it's that process where you take a group of people and you're trying to understand a problem or a domain solution space thing. And as you work on it collectively together, you build vocabulary around things, you build concepts and understanding around different ideas, around different, articulations, and then you build on top of those and you develop your understanding in the space through these iterative layers of understanding. And you can actually see this in language development, where, for example, languages that are in societies that have like permanent ice have so many words for snow. And in English, we have basically just snow because we don't experience it so deeply to need this nuance. But we do, on the other hand, have like in Seattle, 20 different words for rain. And this idea of, okay, if we take this kind of language concept of building these collective understandings and layers on top of each other, I would take that into technical concepts. That's what I think of when I think of abstraction. And it's this emergent process. It's thinking about emergent behavior and emergent understanding. And how do you build the ability for the emergent things to happen? Then how do you let it continue to grow unfettered and evolve organically?
And usually that starts with just the reason we build something on top of it is kind of the convenience factor, right? Like going back all the way back to COBOL, right? Like Grace Hopper, like key figure in making COBOL as a language, as a common language that you can write to that then would compile to all the different bare metal implementations of different assembly, different chips underneath the hood, right? Like COBOL is that first language that is doing that for people. And they're like, actually, I'm going to give up some speed instead of writing assembly code in the actual execution, but I gain speed in writing this common language that is then portable over different chips, right? And that's like the whole reason that exists as I guess you could say an abstraction over those different assembly for those chips, right? And like we're doing that again. It was like, actually, what if I could write to Kubernetes and I can deploy it on top of any infrastructure wherever it's running to say like, that is my new abstraction. I'm giving up some control. I'm adding some complexity under the hood to do the compilation, to do this stuff that maybe I don't understand how it got there, just like compiling a binary. But at the end of the day, I gain speed in the fact that I can consume that interface better, more quickly, just to say like, this is the only thing I need to write to. I need to write Kubernetes, and everything else under the hood is going to be figured out somewhere else.
I think it's really just a lot of trying to figure out how we allow humans to interact and to have like a way of communicating with computers, right? Like it's just different ways of giving computers instructions, but in a way that you're meeting humans at different like readability levels and different levels of being able to communicate with computers. Because if you think about it, like Java made it where it was easier to write, it once and then compile on different systems, right? And then COBOL, it was different chips. Like we're just getting close. And then Python is like more readable than for some people than other languages, right? Like they're just these different ways of communicating with a computer to get a certain outcome.
And the Java example is a really good one, right? Because like COBOL's abstracting the hardware, Java is abstracting the operating system, right? It's just like, oh, we're just going to put like this new VM on top of whatever it's running on. Same thing with what Wasm's doing, right? You have this runtime that's portable, and he's like, I'm going to write to the runtime, and then I can deploy that on any operating system and any hardware. And how that gets run again is it's just people saying like, I want this to be. I hate the write once, run anywhere sort of approach. Like that's not 100% factual, but that's the idea, and that's kind of the goal for a lot of these things. And like if we can write that abstraction that is everywhere, then maybe we would have to stop implementing it.
A really funny example that you brought that up, because if you look at the history of DevOps, like the concept, the Agile movement, and the Agile movement actually, one of the origin stories of it is exactly Java. And the failures of Java to truly be a write once, run anywhere. And one of the stories of there is a very specific one of when you had these developers running Windows machines and compiling and writing a Java application, and they did it in a waterfall style of they wrote the whole application, and then they deployed it to production, and production was Solaris. And it was, if it's write once, run anywhere, and you test it locally and it works, it should just work. And it turns out it completely fell over, did not work. They had to basically take the entire thing, rip it out, and rewrite it. And the people like kind of leading the project looked at it and said it was an unmitigated disaster. And how do we make sure that this essentially never happens again? We can't do the write once, run everywhere, but not run it until it's like, so the abstraction became not necessarily the technology, but the process. And so the abstraction and the evolution there was, if it's write once, run anywhere, that's cool. But even if it's not, the better idea around the reusability and around the efficiency is actually that you write something and you can immediately, as soon as possible, figure out whether or not it works. And so that's where the Agile movement started coming from. And that's where DevOps started coming from. And a lot of this continuous integration and continuous development concepts came from is recognizing the fundamental deficiency of not being able to validate something in the context that it's going to actually operate in.
So how does that apply to what you say in the blog post about having commoditized implementations, right? Because you have these abstractions that you want to home build or build yourself in a way that is useful for the humans operating the machine, and then you're going to apply that in a sense of taking off the shelf components and basically gluing them together, right? Like the vendor engineering sort of thing.
Yeah. So the distinction there between the HomeBot, the store-bought implementation and the HomeBot abstraction is, if you think of an abstraction as something that's useful for you, your team, your organization, your company to operate, then the abstraction is really for how does this company get better at doing the company thing. So the most effective abstractions are always going to be so deeply specific to your understanding that they don't necessarily make sense to anybody else. It's not that other people couldn't use them, but it really just does not necessarily make sense. Like, for example, if you work at a company that deals with a whole bunch of distributed databases, you're probably going to develop a lot of really nuanced concepts about consistency models. And if you're a company that just has a generic website and doesn't do a whole lot of things with it, you probably don't have a lot of abstractions and concepts and understanding around consistency models. But you might have ones around like different types of environments or A/B testing or things that are useful for websites. And the implementation, the reason why that's store-bought is because if you build the abstraction on top of your own implementation, you're going to run into the not invented here syndrome kind of thing, and you're going to isolate the entire company from the context of the rest of the development world so much, and it's actually going to hurt you a lot more in the long term. Like, imagine if everybody saw Kubernetes and then said, oh, this is a great idea, but I'm just going to write it from scratch from my own and build these like nice little concepts on top of it. You can build the abstraction, you can build the concept and understanding, but if you rebuild Kubernetes, that's just a waste of time. It's not meaningfully helping you understand the problem better, and it's actually hindering you from understanding the problem better because you can't work with other people at the implementation level.
I think that's one of the things that is underrated about open source is not just the fact that your people are working and making these tools for everyone to use, but the fact that you have like this area of thinking, like a sounding board to make something better from multiple viewpoints and people running things in multiple environments. So you get more of a iteration and validation because other people are using this product in different ways than you are.
I mean, how does that apply for like something like Kafka, right? Like Kafka has a fundamental way of being used or a reason to use it. And then everyone uses it in a different way, right? Like everyone's like, oh, well, everyone's moving messages from one place to another and having some buffer in between. But the actual thing that they're like trying to buffer or why they're buffering it or how much data they're putting through or how fast they need it to go through, all of those vary depending on implementation or use case. And a lot of that comes down to that sort of like abstraction. I almost feel like Hazel, what you're saying is like abstraction is more than just the technology bits, right? Like it's the process of the business, right? Like how we get work done, how the org is structured, that needs to be baked into the abstraction more than just the technology implementation of like, here's a WordPress website, I'm going to make that as easy as to deploy. It's like, actually, if you have an internal group creating WordPress websites versus external customers creating WordPress websites, like that abstraction needs to look different because of the interface you have between the people making or using the abstraction and the people creating and maintaining the abstraction.
Absolutely. And when you take that and you expand beyond just the technology people, it gets even more important, and the distinction between the implementation and the abstraction gets a whole lot more profound and in some cases obvious. So like for the WordPress example, you can think of, well, how do internally we think about websites? How do other people in the company know that they need one? How do they talk to developers? How do they talk to designers? How do developers talk to non-developers about what we need out of what we're building? And how do we even think about that? So we can talk about, images and a bunch of images on a page, but that's not a gallery until you call it a gallery. If you talk about a website, it can be, a bunch of pages stuck together, but is it a landing page? That's different. And what does a landing page mean to you? Maybe you have a concept of what a funnel is. And if you write funnels often enough, you might actually make a funnel construct for WordPress that works for your particular marketing team's implementation and your particular sales team's strategy. And that's not going to actually be universal. The universal implementation might be, we need custom types, we need like a form, we need, we're not going to rebuild our own form software, but what does a funnel look like? It's going to be different for every company, and it has to be.
Well, I'm here with a good friend of mine, David Shu, over at Retool. Big fan of Retool. Big fan of internal tools built with Retool. But David, not everybody knows how to use Retool. what can't you build with Retool?
Yeah, so Retool is really good for building any sort of CRUD application where you care mostly about security, authentication, authorization, sort of internal-facing things, basically. If you're looking to build, let's say like Google Maps, for example, probably you should not be using Retool for that. Go write some custom JavaScript or React, in order to go build a really complex application like Google Maps. But if you're looking to build a CRUD app, Retool's great for that. And what we see especially is that backend engineers who have less experience at the front end or less interest in the front end really gravitate towards Retool. Because for a backend engineer, sometimes all you want to do is you want to get a form and type your database, test that it's working. You want to go test that API, for example. And spinning up a quick app in Retool is so much faster. They're trying to go learn React, learn Redux, learn state management, learn all these different parts of the front end stack that it's gotten so complicated. And so I think that backend engineers in particular really gravitate towards Retool for building fast CRUD apps.
Okay, friends, the best way to build internal software is by going to retool.com. You can seamlessly connect databases, build with elegant components, and add your own code on top. You can accelerate mundane tasks by not learning React, not learning Redux, and freeing up the time you need to work on the things that matters most. Once again, retool.com. Start for free or book a demo. Retool.com.
Every time I see an abstraction get rebuilt is usually when there's a new consumer of the abstraction. Once we say that, so someone's going to come and ask, okay, we have this WordPress abstraction. We run it on top of, who knows, some other infrastructure abstraction. But then the business comes and says, how much does it cost us to run each WordPress instance? And if that wasn't thought into the abstraction from the beginning, you're going to bolt on something else that then does some like external measurements. But if you build that into the abstraction of a total cost that a WordPress, whatever the thing you package as a WordPress site, if you have cost as part of that, then you can have this other consumer easily come in and integrate with it and say like, oh, I know how much this one costs, or we can build different sizes of WordPress abstractions that cost us different amounts. And then we can go in and more easily tie that directly to the business. And usually that comes from just like this almost like inflating of the abstraction and saying like, okay, well, we have a really cool tight abstraction, and now we need to bolt on like 5 different things for these different business units to use it for it to make sense to them. And you either bring those into the abstraction or you have other interfaces for those things to work outside of the abstraction.
I think this is also because we put a lot of weight on just being technical, but not a lot of weight on being able to work with other departments to make the business part happen, and to be able to do like processes and to communicate, because a lot of times we want to build something really cool, which is great. We want to be like uber technical. And I think developers are like, it's just like the argument between like Macs and Linux. Like we want Linux when you want to get really choosy about all the different things that you want to add to something. And then sometimes you want a Mac or like a Mac OS because you want it to be more just use it, right? Like that whole conversation we had with that new distribution of Linux that's more, I guess, user-friendly that we were talking to.
George, yeah.
Yes. But if we don't truly understand, like if developers aren't given the option and aren't put in a place to really understand the business needs, and the business needs aren't really able to understand the like technical construction,
what they do, how it ties to the rest of the business,
yeah,
right? Like this is like,
it just seems like it's always this like tug of war. And the more like we have all these different things, like different ways to abstract away, like sometimes abstractions are good, right? Because you only want your developers to be working on the things that they need to know, right? But other times it hides so much that they don't even know what they're working on top of. But I feel like if we could get better communication, like communication is just as important as being technical, because really what we're doing is we're communicating with computers, right? But you also need to be being able to communicate and understand the business to make the right technical decisions.
Yeah. And so as like kind of a concrete example of a abstraction that a lot of companies end up building in some way, but they would benefit from building in a more uniform way, would be personas. Because you end up having your customer base, and you can break the customer base into personas, but do people actually take those personas and build a real abstraction out of them? And it turns out a lot of people don't. Because if you thought about what a real abstraction for personas might look like, in theory, you could take your monitoring and SLOs and observability and all this stuff and sort of drill down by persona and be able to work with, say, your product team to figure out what pricing makes sense based on the volume, the reliability needs, the support team, and what the product success team is doing by persona. And then people can start talking about, oh, we think we have this persona, but it turns out that this persona has very weird behavior where they fit into this bucket in this area and this bucket in this one. Do we have two personas? Or it turns out that this persona is 10% of our revenue and 90% of our traffic. How do we either optimize that or throttle that or renegotiate? Like, what is that? Is that a missed opportunity? Is that an overinvestment? What is that? And you end up, in reality, in the case where people are working on performance and they're just kind of working on it without tying it to the business context. And so they might go, oh, yes, this group of people just kind of really use the website a lot and whatever. We're just going to fix this and make it work so that it doesn't fall over. We're going to handle multi-tenancy over here, but we're just going to kind of handle it in an ad hoc way so that quality, of life for everybody in the application is pretty okay. But you can't communicate that to the rest of the company. And so you just end up with these meaningless sounding OKRs like, we're going to take the 99th percentile of response times and bring them down here. And nobody cares. But if you say something like, oh, this persona accounts for 80% of the revenue and 20% of the volume, so we're going to focus on making their 99th percentile performance really, really smooth. And to do that, we're going to take this, whale type of persona, and we're going to handle them with a throttling strategy. And this other persona is actually a very small one, except it has one customer that is 97% of that entire persona's usage. So that customer is going to get a little bit extra treatment, and we're going to actually talk with the product team and the marketing team, sales, and figure out what do we need to do with our pricing strategy to account for that because it doesn't reflect what's actually happening. Maybe we need a new enterprise tier. And this is a sign because this is weird. Like that is far more compelling than any OKR you could pull up that's just numbers.
That's so true because sometimes you need the story and the context, but also in any other business, you couldn't not know your audience to make a good product for them. And then that's the whole point of the iteration and the, agile. Like if you can go back and get the results and figure out what's working and what's not working, you can better serve your customers, but also better serve your business at the same time.
I mean, but we get blinded by numbers in technology, right? Like the numbers are the easy part.
I think we could do such a better job as a service to like the people working in the business and our customers if we would take that approach of marrying the two and remembering like this is a business, and you need to like.
I do feel like looking back just on my own experiences where developers have been paid so much, they've been seen as this like high off to the side, like you're not allowed to disturb them if you don't work as a developer, that it's been really difficult to bring them back down to earth and say like, we're all working on a business together and we need to work together on the same goal of making customers happy by, making whatever it is that the business does, make that side of it better. And in infrastructure and developers, where you just get blinded by the easy thing of like, that number is really easy to chase. I can lower that number by 10%. I know it. And you're like, that actually doesn't matter. At the end of the day, let's see what is that actually going to do. Right. And so at some point you have to look back at the harder thing of going and talking to people, the people that are your customers or the people that you work with that or the interface to the customers. And that's fair, right? Like I worked in help desk for a long, long time. And if I don't have to, but also like I still work in help desk, right? Like even if my title changes, like I'm still basically the help desk. I'm still out there talking to people.
Specialist solutions architects are really well paid help desk. You know what I mean? Like right. If you look at it, so much of like our jobs, if you're doing it right, you are the help desk. Like, because if you don't know what your customers need and you don't know if you're fulfilling those needs and what is like half the time observability into your product and into your customers is like always is the problem, like it's like when you like are worried if like DNS is the problem and 90% of the time it is DNS, it also is people just completely like sometimes I think as like engineers people get so into the technical details and like the flex of like being so technical and I'm just like there's so much communication
It's also such a cultural thing as well.
Yes, and it's like icky.
We have this huge problem in technology where people think that they want to be left in the corner to just do their own thing. And they think that, being technical is better. And the more technical, the more nerdy you are, the more like all of these non-human elements, the better. Like if you could just unplug my brain and stick it in a vat, like, yes, amazing. And trying to take these types of people and say, you would actually be a lot better at your job if you talked to the non-technical people instead of just insulting them.
Yeah.
Or instead of just looking down at them. And they would go, what? Oh no.
Even the way that roles talk about each other, the way engineers talk about product, the way that like people talk about solutions architects, like it's always like this ridiculous pissing contest, which makes it so much harder to work together.
I love reading people's bios that say like, I love to solve hard problems. And I'm like, oh, you like fixing printers for your family? Like that's like the hard, right? Like level of hard problems is just like go fix a printer for your dad on the phone, right?
No.
Like you're not even there. Like
or explaining any technology to people that were born before like Google and cell phones and all of those things were popular, because it's like the way that my kids will pick up technology and just go, and then the way of trying to teach it to an older family member is painful.
Hard problems, hard problems. And I mean, I think what we've kind of all agreed on here is like everyone at the company is part of customer service. Everyone is part of sales. And in my opinion, everyone's also part of recruiting, right? Like those are the three things that if you work at a company, you're doing it no matter what. Doesn't matter what your title is. You have those three things.
And if you're not doing it or you don't think you're doing it, you are doing it, but you're doing it badly. And you're actually probably doing the opposite
you're
of
doing
what
the
you
negative.
And that's not great for the company or for you either. But like even just going back into, you're part of the help desk, you're part of, and you know what's really great about being part of the help desk? You have this really good, really refined, intuition of what can be automated, what can't be automated, and you should be working on that. And one of the best ways to work on that, and one of the highest leverage ways to do it, is internal tooling for non-technical people. Nothing humbles you more than going, I built this thing, it made sense, and everybody's like, why the is the button in the wrong spot? And you're like, okay, what? And they're like, okay, I don't get it at all, actually. I get none of this. What do you mean this is basically just like get what, but what? And so you have to actually make things understandable for people. But also, when you work on internal tooling for non-technical people, it ends up being such a massive leverage point, such a massive influencing point, and such a massive return on investment that it's shocking that people don't do this in companies. Like I've yet to see a company where you have someone saying independently, oh, I'm going to build an internal tool for the help desk people because they spend 60% of their time on this one type of problem. And I could just build this in an hour or two, and then it would help so many people. And you can't do that because that's a waste of time. And I'm like, no. So like at a previous company, we had DNS records and we had S3 buckets. A lot of clients would want to, do S3 bucket direct transfer, but that requires clicking a couple buttons, setting up a couple things, and touching AWS somewhere. And so the help desk people and the solution people would, talk to the DevOps like types of teams, and those teams were overloaded with busy work of basically helping the help desk. And I'm like, these teams are underwater. They don't have time for this. It would take literally 2 days to just build something that you take a bunch of forms, you fill it out, and then on the backside it does a bunch of hideous selling out to a bash script that just creates all this stuff. It's fine. It doesn't need to be amazing. And I never actually got permission to build that. And I was like, this is stupid.
Companies that don't let people fix their own problem have other issues, right?
Right.
But there's also no incentive at most companies to work together in that manner.
Well, if anything, there is disincentive.
Exactly.
Like you're actively punished.
Exactly. Which is like, I feel like I just wonder, like, where, like, since we're in this weird sunken place of tech, like, when will people realize that you do need those cross-team skills and those communication skills and process skills to also make you a better engineer?
I was hoping that the zero interest rate phenomenon would give people the space and the time and the ease of exploration, because investment is so low risk, to figure out a lot of these problems and these social problems and these, how do you actually help the business and how do you actually do all these things and incentivize the right results. And it ended up having the opposite effect. And so my new hope is that in all of the hard times around the whiplash of the market, from transitioning from zero interest rate to high interest rate and all these tightenings of the belts, is going to get people hopefully forced to look beyond, tomorrow and look beyond their neighbors and go, what actually makes the business more effective outside of my preconceived notions of what I should be doing and how I deliver value. Like, if I can look outside that box, what are the options? What are the possibilities? And I hope we get there as an industry. And if not, I'm willing to drag them kicking and screaming.
Drag them, Hazel. Drag them.
I know we will have more conversations in the future, whether in person or more podcasts. Hazel, where can people find you online?
You can find me at hazelweakly.me. You can also find me on Blue Sky, Mastodon, and LinkedIn. I'm sure you can find me in other places, but I wouldn't really recommend it because that's kind of weird.
You can also find them at Coffee with Me a lot because we're just about to be besties.
We're going to be besties. It's going to be great.
Thank you so much for coming on the show, and thank you everyone for listening. If you have other ideas, your own ideas about platform, and maybe even I would love to hear how people stretched across those boundaries of where they were working and teams they worked with to add business value or make an abstraction that kind of cross those barriers. I love hearing those stories. So please reach out to us. It's shipit@changelog.com, and we will talk to you all again soon.
Also, can we vote Hazel like president of all infrastructure and platforms and technology? Because it would be such a better place if we let them do it.
I mean, I am wearing a very queenly outfit.
Look, I'm your first vote. I'll do the campaigning for you.
Let's do it.
All right. Thank you so much.
3, 2, 1.
Thanks for listening to Ship It with Justin Garrison and Autumn Nash. If you haven't checked out our changelog newsletter, do yourself a favor and head to changelog.com/news. There you'll find 29 reasons, yes, 29 reasons why you should subscribe. I'll tell you reason number 17, you might actually start looking forward to Mondays.
Sounds like somebody's got a case of the Mondays.
28 more reasons are waiting for you at changelog.com/news. Thanks again to our partners at Fly.io. Over 3 million apps have launched on Fly, and you can too in 5 minutes or less. Learn more at Fly.io. And thanks, of course, to our Beat Freak in residence. We couldn't bump the best beats in the biz without Breakmaster Cylinder. That's all for now, but come back next week when we continue discussing everything that happens after Git Push.
Okay.